Students were already given time to complete the multiplication at the top of page 29. And as I explained already, I'm going to go through the two problems at the bottom of the page, and then the rest of the period is for students. Okay, so we're going to get right into it. Before I start either of these problems, I'd like to point out we are doing the exact same problem twice. That's on purpose. That was not a typo on my part. Okay, on your test next week on Friday, you might be given an equation like x squared plus 14x minus 83 and asked to solve it. Now, I might tell you the method I want you to use. I might say to you, you have to use the complete the square method. Or I might say to you, you have to use the quadratic formula. Or I might say to you, you have to use the square root method. Or I might say to you, you have to graph it and find the x-intercepts. Those are the four methods that we've learned for how to solve these quadratic equations. And you're responsible for knowing how to do all four of them. Now, because we're doing the exact same question twice here, okay, it shouldn't shock you that we're going to get the same answer both times. Okay, but I want to kind of give you an overview of both methods. All right, so let me start with writing in red. Please do not copy this. If you want to complete the square, the whole point is to be able to factor this thing very quickly. And there's a nice little trick. You can take the square root of the first term, square root of the last term, and then look at the sign in the middle. Okay, bless you. That's sort of the shortcut for being able to do this. The problem is, remember I said don't write because red is bad. The problem with this is that negative 83 is not the number we need. This strategy only works if there's a very special relationship between the middle number 14 and the last number. And negative 83 ain't that number. Okay, the special relationship is that you have to take the 14, cut it in half, which is 7, and square that value, which is 49. So it turns out if instead of the negative 83, if instead we had a 49, we would be able to factor this thing very, very quickly. This is why step 1 is add 83 to both sides. Get rid of the number you don't want. Okay, so please go ahead and copy now that 83. That's the first blue thing that's on the screen. So that should definitely be part of your notes. Now, at this point, you'd have to do the math in your head or, maybe type it into a calculator, but you want to figure out now that you've gotten rid of the 83, what number do you need? Which again, you just take 14, cut in half, square it, and then you realize, oh, if I had a 49, then it would turn this into something that I can factor very quickly. So I'm going to add 49 to both sides. And now you can factor this thing very, very quickly. All you have to do to factor it is take the square root of the first term, square root of the last term, and pay attention to that first sign. The square root of x squared is x. The square root of 49 is positive or negative 7, and this is a positive, so I want the positive 7. And then 83 plus 49 is 132. And what I would argue is that by following these steps, you turn a really difficult equation into something you can solve in 2 steps. Now those 2 steps are take the square root of both sides. That gets you plus or minus the square root of 132 on the right. By the way, square root of 132, that is not a clean number. So you're not expected to do anything with it. You can just leave it as square root of 132. And the only other thing you have left to do is subtract 7 from both sides. So again, the blue there would be your final answer. I do not expect you to get those decimal values. If you really want to, if you want to type negative 7 minus the square root of 32, if you really want to do this, and you want to do negative 7 plus the square root of 32, I have no problem with that. You can tell me those are your answers, negative 18.489 and positive 4.489. But you do not have to. You can stop at negative 7 plus or minus the square root of 132. Okay? Now, we're going to do this a second time. We're going to solve the exact same equation, but now we're going to use a completely different method. Okay? So now we're going to solve this using the quadratic formula. Now, to be able to use the quadratic formula, you first have to recognize that you have 1x squared, you have 14 x's, and then you have negative 83 at the end by itself. Those are your A, B, and C values. When you set up the quadratic formula, and again, that formula will be given to you, just like it's given to you here. Quadratic formula will be given to you on your test next week on Friday. Okay? Remember, the A value gets used twice. The B value gets used twice. The C value of negative 83 only gets used once. Now, the very beginning, the negative 14 and the bottom, the 2 times 1, those parts I would say are pretty straightforward. Okay, negative 14 is just negative 14, and 2 times 1 is 2. But figuring out the number inside that square root, that's a little obnoxious. That's what I'm going to use my calculator for. I'm going to type all that stuff inside the square root in my calculator. 14 squared minus 4 times 1 times negative 83. 14 squared minus 4 times 1 times negative 83. And I get 528. Now, the square root of 528 is some crazy decimal, so you don't need to do anything with it. As far as I'm concerned, that is your final answer. Now, this is where I'm hoping somebody is willing to point out something that makes no sense. Yeah. I am leaving it like that, but I'm allowed to leave it like that because the square root of 528 is some ugly, hideous number. What do you notice about these two problems where we solved the exact same equation? What about the answers? They look different. That's the key. So check this out. I love that Toprick is able to point this out for everybody. I told you we solved the same equation twice. We should get the same answer. And yet, we got two answers that look totally different. Well, believe it or not, those answers are the same. They look different, but they are exactly the same. If you do negative 7 plus or minus the square root of 132, that is the same exact thing you'll get if you do negative 14 minus the square root of 528 divided by 2. I'll prove it to you. Here's what I'm claiming. Negative 7 minus the square root of 132 and negative 7 plus the square root of 132. Those are the answers we got in number 1, but this is exactly the same thing as, what was it, 14 minus negative 14, and it is because we're dividing. You're absolutely right. Negative 14 minus the square root of 528 divided by 2. It's the exact same decimal. And if I did negative 14 plus the square root of 528 divided by 2, I get the exact same decimal. This is one of the reasons why I keep saying I'm not expecting you to take it further. Once you get to that square root form, you're good. I know that these two answers look different, but they are the exact same answer.